Hi everyone, today's topic is assignment problems in operations research. This is the question: how should the jobs be allocated one per employee so as to minimize the total man hours? Here in this problem we have 5 employees and 5 jobs. Now our objective is to assign one job to each employee. Assign one job to each employee. A, B, C, D, E are the jobs, and 1, 2, 3, 4, 5 are employees. So, from the given data, employee 1 can finish job A in 10 hours, and employee 1 can finish the job B in 3 hours. Employee 1 can finish the job C in 10 hours, and job D in 7 hours, and E in 7 hours. Likewise, all the employees, these are the times given by the problem for the time taken by the employee to finish a job in hours. Now our aim is to minimize the total man hours and assigning one to minimize the total man hours, assign a job to a employee. So in assignment problems we use Hungarian method to solve these problems. So in Hungarian method, the first step is from the given matrix, observe each row. From each row, take the least element. First step is row reduction. So from the first row, take the least element. Here in the first row, 5 is the least element. Subtract that 5 from the remaining elements. Likewise, in the second row, take the least element, subtract that least element from all the remaining elements. Continue this process to the remaining rows. So first step is row reduction, and then the next step is column reduction. First we do the row reduction. In the first row, the least element is 5. The least element is 5. So 10 minus 5 is 5. 5 minus 5, 0. 13 minus 5, 8. 15 minus 5, 10. 16 minus 5, 11. Second row, the least element is 3. So subtract 3 from all the elements in the second row. 3 minus 3, 0. 9 minus 3, 6. 18 minus 3, 15. 13 minus 3, 10. And 6 minus 3, 3. Third row, the least element is 2. So subtract 2 from the third row elements. 10 minus 2, 8. 7 minus 2, 5. 2 minus 2, 0. 0. 0. In the fourth row, the least element is 7. So subtract that element. 7 minus 7, 0. 11 minus 7, 4. 9 minus 7, 2. 7 minus 7, 0. 12 minus 7, 5. In the fourth row, the least element is again 4. So subtract 4 from all the elements. 7 minus 4, 3. 9 minus 4, 5. 10 minus 4, 6. 4 minus 4, 0. And 12 minus 4, 8. So this is row reduction. So after doing the row reduction, for the resultant matrix, do the column reduction. That means first observe the first column, take the least element, subtract that least element from all the elements of the first column. So in the first column, 0 is the least element. So 5 minus 0 is 0, 0 minus 0, 8 minus 0. So again in the second column, take the least element, subtract that least element. In the third column, take the least element, subtract that least element from all the elements. So in the first column, the least element is 0. So the next matrix is 5 minus 0, 5. 0 minus 0, 0. And 8 minus 0, 8. 0 minus 0, 3 minus 0, 3. In the second column, least element is 0. So 0, 6 minus 0, 6, 5 minus 0, 5, 4 minus 0, 4, and 5 minus 0, 5. In the third column also 0 is there, so all the elements are as it is. In the fourth column also having 0, so all the elements are as it is because we are subtracting from 0. And fifth column also 0 is there, so all the elements are as it is. So this is row reduction and this is column reduction. After reducing into by the column reduction, now assign the zeros. So this is the matrix from here to here. Okay, now assign single zero. Now observe this matrix, the same matrix I have written here. Observe the first row. Observe the rows with single zeros. So here in the first row we have single zero, so assign that 0 with a box. So in this row we have assigned 1 0. In the assigned column, if there is any 0, strike off that 0. Now there is no other 0 in this column, so no need to strike off. In the second row we have single 0, so assign this 0. Corresponding to this assignment, in this column there is another 0, so strike off that 0. Now in the third row we have 3 zeros, so leave it. In the fourth row we have only one single 0, so assign that single 0. So in row we are assigning, so strike off the remaining zeros in that column. In the last row there are no zeros. Now after row assignment, do column assignments. In the first column no zeros, second column no zeros, empty. In the third column we have one single 0, assign that single 0. In column we are assigning, so in the corresponding row there is a 0, strike off that 0. And here no zeros, no zeros. So in overall we have assigned only 4 zeros. That means we have assigned only 4 jobs to the employees, but our aim is to assign all 5 jobs to each employee. Now we have to do the further process. For that process, first what we need to do is cover all these assigned and striked off zeros with minimum lines. Cover all these striked off and assigned zeros with minimum lines. Now I am covering, see. So all the striked off zeros and assigned zeros are covered. Now here there are some elements which are uncovered, 6, 15, 3, 4, 2, 5, 8, 3, 6. So among all these uncovered elements, so what is the least element? 2. 2 is the least element. So add this 2 at the point of intersection of two lines and subtract this 2 from the uncovered elements, and the elements under the line are as it is in the next table. Once again I will repeat, add this least element 2 at the point of intersection and subtract this 2 from the uncovered elements, and the elements under the line are as it is in the next table. So in the next table, this is the point of intersection, so add here 5 is there, add 2 here, 5 plus 2, 7. This is the number under the line, so these numbers are as it is. And next, this is the point of intersection, so add 2, 10 plus 2, 12, and this is the number under the line, which is 11. Next, 0. This is uncovered element, subtract 2 from here, 6 minus 2 is 4. This is also uncovered element, so 15 minus 2, 13. 10 is under the line, so 10 as it is. 3 uncovered element, 3 minus 2 is 1. Now 8 is the point of intersection, 8 minus 2, 6. and 5 is under the line, 5, 0. This is the point of intersection, so add 2, and just this is under the line. Okay, now 0, 3, 4 minus 2. 4 is uncovered element, 4 minus 2 is 2, 2 minus 2 is 0, 0, and 5 uncovered, 5 minus 2, 3, and here 3 is there, 3 minus 2, 1, 6 minus 2, 4, 0, 8 minus 2, 6. So this is our new table. So here 1, 2, 3, 4, 5 are employees. A, B, C, D, E are jobs. Now again assign the zeros. First observe this first row. Single 0 is there, assign that single 0. Now here single 0 is there, assign this single 0, and in the corresponding column another 0 is there, strike off that 0. In here we have 2 zeros, so leave this, and here we have 2 zeros, leave this. Here we have a single 0, so assign this single 0. Since we are assigning in the rows, strike off the zeros in that corresponding column. Now row assignment over. Now take the column assignments. In the first column zeros are assigned, here also assigned, here 2 zeros are there, leave it, and here also assigned. In the third last column only 1 0 is there, so assign this 0. Since we are assigning in the column, strike off the remaining zeros in that row. Okay, these assignments are over. Finally again row reduction, no zeros, no zeros, no zeros, only single 0 is there, so assign this 0. So all the 1, 2, 3, 4, 5 zeros are assigned. So we have assigned 5 jobs. Okay, now we will find out the minimum time of this taken by these 5 jobs. See here, job A is assigned to second person, job B is assigned to first person, job C is assigned to fifth person, D is assigned to third one, and E is assigned to the fourth person. So here we have taken that A is assigned to 2, B to 1, C to 5, D to 3, E to 4. So from the first table, A to 2, A can do the job. The job A can be done by the second employee in 5 hours. So take that 5 here, take that 5 here, and the job B can be done by the first employee in 3 hours, and job 5 can be done in 2 hours, 3 can be employee 3 can do the job in 9 hours, and 4 can do the job in 4 hours. Total 23 hours. So the total minimum man hours is 23 hours. If you like this video, share, subscribe, and make a comment.